Hi there. In this video, I'm going to demonstrate the data sync capabilities we're building into Red Hat Managed Integration, also known as RHMI. So we're starting off in the RHMI Solution Explorer. From here, we can go to the data sync walkthrough, which we'll follow throughout this video. Everything we're going to cover is in the walkthrough, so you can try this yourself if you're interested. RHMI Data Sync is a framework for building GraphQL-based APIs and applications with real-time sync capabilities, the ability to work fully offline, and perform conflict detection and resolution. It's based on two upstream components. GraphBack allows you to define your data model, or simply the data or objects your application works with, and based on that, it can generate a fully functional GraphQL API against a real database. There's also an integration with RHSSO for adding authentication and role-based authorization to your backend APIs and applications, and there's also an integration with AIMQ Online to provide a production-ready messaging backend that supports the real-time capabilities in your app. Lastly, Offix is a specialized GraphQL client that you can use in your mobile or progressive web apps to interact with the server and build fully offline workflows. So let's get started. The walkthrough takes us through the Data Sync Starter project, which shows off the core features of the sync framework. It's also a good template you can use to get started building your own applications. Next, we're going to set up and browse the project in Code-Ready Workspaces. Code-Ready Workspaces is a web-based IDE that's included in RHMI clusters. Of course, you could do all of this locally too, but it's just a little bit easier in Code-Ready because we can have pre-configured environments that has everything set up already. So here you can see the GitHub repo for the DataSync Starter application. If you're interested, do check it out. There are instructions in the README for setting up locally and within OpenShift. So here we are in Code-Ready. The repo contains a Node.js server application that was generated by GraphBack. You can see it here in the server folder. It's written in TypeScript. You can see here's the index.ts file. There's also a React-based front-end application. This application uses Offix Client to talk to the server. The overall app is a typical to-do MVC style app, but with real-time updates, the ability to work offline, and conflict resolution features. Now we're looking at the GraphQL RC file. This is a config file that GraphBack uses when generating your project. In here you can pick what types of data access methods you want enabled. So for example, create, update, delete, find all, and so on. They're based on a CRUD model. You can also enable and configure various plugins that will affect the resulting code generation. Next we'll look at the model file. This is where you define the model or the objects your application works with. The syntax you're looking at is GraphQL Schema Definition Language, or SDL. Here we're defining a partial GraphQL schema. GraphBack will read that and generate a fully functional API that works against the database. Let's take a look at an example. Here we have an example task model that has some fields like ID and title and description and status. The model annotation tells GraphBack to treat the task as a model. This results in various CRUD operations being generated. We'll also add the datasync annotation, which tells GraphBack to add additional datasync capabilities to the resulting business logic. Lastly, we'll also add another field just to see how that affects the generation. So let's run the generate source code command on the right hand side. This is running the GraphBack CLI, which is a Node.js based CLI tool that does the generation. We can see that the generation has been successful, and this results in several new files being created in the repo. So if we take a look in the Git Explorer on the left hand side, we can see all the new files that were created. The one that we're going to look at first is a schema.graphql file. So if we compare this to the model file we were looking at earlier, we can see we've still got our task model, but this time we've actually got a version field added in here. This was added by the datasync annotation that we defined. We've also got all the operations that our API is able to perform. So for example, we've got our mutations like create task, update task, and delete task. And we've also got our queries like find all tasks and find a particular task using a filter. The generated resolvers file contains the actual business logic implementations for those operations that we saw in the schema. So for example, we've got find all tasks, find tasks, and then we've got our mutations like create task, update task, and delete task. These functions are actually resulting in queries that hit our database and return a result that go back to our client. We've also got our subscription resolvers, which implement the real-time aspects of our app. There are several more files generated too. These files have been generated and placed in our client application. They are the client queries and mutations that our client application can send to our server to access and modify data. They are based on the schema that the server has. So when we modify our model and regenerate our server, we also get brand new queries and mutations that we can use within our application straight away. The generate command is not something you only run once. You can make changes to your model as much as you like and rerun the generate command again. Let's take a look at that in action. So here we're going to take the task type and rename it to the to-do type instead. And then we're going to rerun the generate command and see what happens. Okay, so we can see the generation was successful. Let's take a look at the files in the Git Explorer again and see what we have. So now we can see that we have a bunch of different files now. Let's take a look at the schema again and see what's different. Okay, now we can see that we've got a to-do type now instead. And we can also see that our queries and mutations have different names now. So now we have create to do, update to do, delete to do, and so on. We can also go to our resolvers file and see the implementations for those have changed slightly as well. And lastly, we can see that the client queries and mutations have all been regenerated as well with new file names. So let's get on to running the server. We're going to run the server from within CodeReady. All these steps are in the walkthrough, by the way, so you can follow these yourself. So we got a command here called prepare client. This just builds the React app and copies it into a folder that the server uses to serve it as a static application. So we're going to wait for that build to complete. Okay, so now the application is built, so we're going to run the start server command. By the way, this server application is using MongoDB as the database, but Graph-Back also supports PostgreSQL and SQLite as well. Okay, so our application is running. We get a little pop-up here, and then we're able to load the application in a little window. We see this not available thing for a second because of how OpenShift routers work, but if we refresh a couple of times, we get the app. So here's the client app. Like I said before, it's like a to-do MVC type app. We're going to add a task here and just make sure that it's working. The app is using the Ionic framework, so the app can be run in a web browser as a progressive web app, and it can also be run as a mobile application too. So let's take a look at the GraphQL playground. The GraphQL playground is served directly by the GraphQL API itself. It's normally enabled during development, and it's not enabled in production. It's a simple web application that lets you explore the server schema and run queries and mutations directly against it. It's just a very handy tool, especially when developing new features in the backend. So you can see here on the right hand side that we've got our GraphQL schema. You can see we've got our task type, and you can also see that we've got our queries and our mutations. And then on the left hand side, we can define queries and mutations that will actually run against the server. So we can see a query here called find all tasks. This is going to get all the tasks back from the server. We can see that there's one result here because it's the task that we created earlier on. So we can also see we've got a create task mutation here. So this is going to ask the server to create a task, and you can see we're passing some arguments here like title and description and so on. All of this syntax, by the way, again is GraphQL syntax, which you can look up on graphql.org. You can see here we got the result that we were looking for. We can also go to the previous application window, and we can see the new task has been added there too. This is a result of our real-time capabilities within the application. Let's look at that a little bit further. So real-time updates are powered by something called GraphQL subscriptions. They allow the client to subscribe to events that they are interested in and the server can send them to the client via WebSockets in real time. Let's create a task on the client on the left-hand side and see what happens. So we can see that the task immediately shows up on the right-hand side. We didn't have to refresh the page. The client wasn't doing any fetching under the hood. This was sent by the server. You can also see if we make some updates that they get reflected instantly too. In a production scenario where you want to scale this across multiple servers, you need a publish subscribe or pub sub mechanism to achieve this. We provide integrations with Red Hat AMQ Online, which is available in RHMI. Next, we'll take a look at some of the offline features. So we're going to go offline in the application on the right hand side. You can see in the bottom right corner that it says offline now, and we're going to create a task. The Office client allows us to interact with our offline data as if we're still online. It queues all the things that we're doing, and when we come back online, it syncs them all back to the server. So you can see we've created a new task on the second client. It doesn't appear on the first client because the second client is offline. We can also make subsequent changes to our offline data, and those will be reflected in our UI as well. Now, when we come back online, the operations that we performed are going to be sent back to the server in the order that we originally did them. Now you can see the new task on the client on the left-hand side too. Applications with those types of offline features inevitably have to deal with conflicts. Conflicts tend to happen when two or more clients try to modify the same data. Sometimes one client's changes are based on data that is now outdated. These situations can be complex, and the way we deal with them can be very specific to a particular application's use case. Office Client has pluggable conflict detection and resolution, which means a developer can define when a conflict should happen in their given application, and they can also decide how to resolve conflicts too. The client also has a good default strategy that uses a version field, which was shown in the GraphQL schema earlier in the video. So let's take a look at an example conflict. We're going to create a new task to work with first. Then we're going to take both devices offline and make some changes. So now both devices are offline. Let's make a change on each device and see how the conflict is dealt with. So on the left-hand side device, we're going to make a change to the description field. And then on the right-hand side device, we're going to make a change to the title field. So now we're going to come back online on the left device first. That means their changes will be synced up to the server. Then we'll come online on the device on the right, and they will experience a conflict. So a conflict occurred, but because we made changes to two different fields on each device, we were able to merge the changes together, resulting in a new task being shown on both devices. This is just one of the default strategies you can use. Next, let's look at how we can secure our application using RHSSO. Red Hat SSO is a standalone identity management service that helps you add features to your application, such as user management, authentication and authorization, single sign-on, and much more. It's provided in RHMI as a managed service. We're going to start by adding authentication to our application so that we have to log in when the app starts. And then we'll add role-based authorization so only certain types of users can perform certain actions. So we've still got our application running here in Code Ready. And then we're going to go to the Solution Explorer, and then we're going to navigate to the RHSSO console. There's quite a bit of configuration needed on the SSO side, so we've got a pre-configured realm here already that we can use within the app. So we've got this data sync starter realm. It's got a couple of users and a couple of clients. Let's just take a look. So we've got an admin user and we've got a developer user. And each of those users also has a role assigned to them. So the admin user has an admin role and the developer user has a developer role. And then we've got our DataSync starter public client. And this is the client we're going to use to authenticate our application against. In a production scenario, you'd probably want two clients, a bearer client for the API and a public client for your front end. But to make things simple, we're just going with one client here. The client is pretty standard. We're using all the default configs. The only thing we're really changing is just adding the application's redirect URI. So to use this client in our application, we just need to go and copy the installation config and bring it into our app. So we just need to copy that config and then we bring it into our application. So we're going to go back to code ready and then we're going to copy the contents of that into two different files. One file is for the client application and one file is for the server application. So the application just has a couple of placeholder files that we're going to replace. We're just going to speed past this bit. By the way, the walkthrough has instructions for how to do all of this, including setting up the realm in SSO, which we skipped at the beginning. So now we've copied those two files in. Let's open up the application in a new window, and then we're going to refresh the page. Now you can see that we're greeted with the SSO login screen. So we're going to log in as the developer user. So not much has changed, but if you look in the top right corner, you can see there are a couple of extra icons. We're going to click up here and take a look. So this is just a profile page. It just shows some information about the logged in user. You can see the username and email and things like that. And you can also see the roles assigned to the user. This all comes from the user profile in SSO. So next we're going to see how we can add role-based authorization to our app. So we're going to make it so that only users with the admin role can delete tasks. So we're going to go into our GraphQL schema here, and we're going to add a special directive. So in our framework, we've added SSO integration, which allows us to do things like add this hasRole directive here. In a generic sense, directives allow us to declaratively change the behavior or execution in the server. In this instance, the hasRole directive ensures the logged in SSO user can perform the delete task mutation. You can use this directive on queries and mutations, but you can also use it to restrict access on individual fields or even entire objects. So we're going to restart the server and then we're going to see this in action. So we're in a new application window. You can see we're logged in as the developer user, so we shouldn't be able to delete tasks. You see when we try to delete the task, it doesn't disappear. Now our app is still under progress, so we've got a console error coming here as opposed to something showing up in the UI. But you can see the message there that the user doesn't have the right role. Now we're going to log out and log back in as the admin user, and this time we should be able to delete tasks. And there we have it. That concludes our demo. Thank you for watching our video. We hope you enjoyed it. If you're interested in learning more, get in touch and request an evaluation of RHMI, or you can get involved in our upstream communities.